My name is Matt Dombrowski. I was assigned to do a project for our Physics 1550 class for everyday physics at Lakeland Community College. Our assignment was to do a project to show some of the principles or a principle that we learned in our textbook over the semester. So one of the interesting ones that I got a kick out of, not only learning about but obviously doing, as you will see, is the Bernoulli's principle. So this is actually Bernoulli's equation. If you don't know anything about physics, you're probably looking at letters and numbers and what is going on. So right below here, what this equation is saying is that pressure plus half the density times the square of the velocity, the speed of the fluid, is going to equal constant. Now what that means is if any one of these changes, whether it's the pressure, the density, or the velocity, that one of these other ones needs to change so that this remains constant. Now that falls under the conservation of energy. Now what that means is that no energy can just magically appear or be formed. Everything has to come from something. So if you're going to have a change in pressure, you will have a change in velocity. And specifically what Bernoulli's principle really tries to explain is that when you have high pressure, you have low velocity. So if you have a high velocity, you have low pressure. So to better illustrate that, I'd like to kind of show what happens with water. Just a basic hose, nothing too crazy going on here. A little stop, get the water going. And I have just a golf ball. I ended up drawing a black line on one of the sides to try and show if it's rotating. We're just going to put this right in this stream. Now, what you're seeing here is this water coming up is now creating this low pressure area that this ball wants to sit into. Now because it has reduced that pressure, this stream now has increased velocity going up. So you have your low pressure, which is centering the ball, and then you have high pressure on the side, which is stabilizing it. So this wants to stay in that happy place, the equilibrium we'll call it. So that's what's going on with this. Now, the next thing is we'll show what it looks like with air. You can do this same experiment with a ping pong ball and a straw. Now, the only straw we had was going to be one that's actually at a 45-degree angle. We do have a little bit of wind going on, which is going to affect this a little bit, but let's see if we can do exactly what we saw over there, but with our air. Now my lungs are only going to be able to hold so much pressure, and it's probably not going to be consistent or constant. So you're going to see that ball moving around a little bit, and that's also why it fell down. So we'll do it one more time. Okay. So, to be a little more consistent, let's try something different. Instead of my lungs, let's use a hairdryer. Now you can see a much more consistent flow is going out, which is stabilizing the ball. It is hanging out in that low pressure area. Now, as I said, right in the stream of this high velocity air is this low pressure area. So where the lower velocity air is around it has a higher pressure. So what's kind of going on is we have this high velocity air. which is creating an area of low pressure. On either end, you've got the higher pressure. Well, this wants to come into itself. So by stabilizing on all around, basically, because you can imagine this is just a linear line, it creates a wall of high pressure. So that ball wants to just stay and hang out there. And as you can see, just with the straw, once I then lose that velocity from the air, low pressure goes away, ball falls down. So, we got to see the idea behind what was going on with water, to illustrate a little bit more. We got to see a straw and the ping pong ball. Then we got to move up a little more and do a hair dryer. But what happens if we go with something a little more extreme, like a commercial leaf blower and a dodgeball? So what we're doing here to try and help center is I just created a basic stop so that this PVC pipe that I ended up making is a 90. This air is going to come out from here through the 90 and going up, and we are going to see if we can stabilize this rather substantial size dodgeball.
Five hours later.
So once again, we're utilizing the same principle. High velocity is going to create a lower pressure, which is going to help to keep this ball from falling out of that low pressure area. Now the exciting part that I won't be able to speak through, but we'll be able to show, is this doesn't need to be 90 degrees. If you have a high enough velocity, you can end up keeping that low pressure zone out far enough that you can now keep it at a different degree away. So that is now showing how strong that force can really be, assuming you can create, as we saw on the equation, a high enough velocity. So the idea was to show that once again, you can only go so far. The equation needs to end up being centered up so that you have enough velocity to be able to hold that up. Once your pressures equalize, also gravity comes into play. That weight is why the ball ended up falling out. So right now you can kind of see folding over. This is going to be the same principle, just seeing it a little differently. If I blow over this piece of paper, you would like to think it shouldn't affect it whatsoever. I'm going to blow over it, nothing changed. What is changing, however, is the pressure. Because of the increased velocity, we are causing a pressure change, turning this into low pressure. By that low pressure change, the higher pressure wants to come up to meet equilibrium. So, to show this, so as you can see, it goes from just hanging out down to raising up. Now, why is that important? Well, the important aspect of that also helps to explain why planes are able to fly. So in this illustration, that is why they designed wings to be a certain way. This would be the top of an airplane wing. As you can see, it has a longer path for that air to travel. So as this is moving through, this air needs to go a higher velocity to travel the same distance as the bottom of the wing. because of that higher velocity, we are lowering the pressure. Now, once again, equilibrium, very important. Because of this low pressure, high pressure wants to come and say hello to create equilibrium. And that is how we have lift. So, super exciting to be able to now take a physics principle and go into that. And as we were able to do before, ping pong ball straw, move it up a little bit. Then we went to leaf blower to really go crazy. So seeing a piece of paper, that's fun. But what happens if we had a real long piece of paper and a whole lot more air? Well, there you have it, hopefully. You now understand the Bernoulli's principle just a little bit more. And I'm going to clean up this mess. Thank you.